I'm Manuel, and this is Exoplanet Lecture Review. Sarah Seeger was the speaker in this lecture, and she is a class of 1941 professor of planetary sciences and a professor in physics and aeronautics and astronautics at the Massachusetts Institute of Technology. Among other accolades, Professor Seeger is a member of the National Academy of Sciences, a 2013 MacArthur Fellow, and featured in the 2022 Emmy-winning documentary. Seeger's research has built in the foundation for the field of exoplanet atmospheres, and her current research pioneers in characterizing exoplanet atmospheres and developing future searches for signs of life based on atmospheric biosignature gases. Over 5,197 exoplanets, or planets outside the solar system, are known to orbit nearby stars. A subset of exoplanets called transiting planets pass in front of and behind stars that are seen from Earth. Their physical properties, such as average density and atmospheric thermal emission, can now be measured. Seeger's group aims to understand their atmospheric composition and their interior structure. She is involved with several space-based exoplanet searches, and as the Deputy Science Director for the MIT-led NASA mission TESS, as the PI for an on-orbit JPL MIT CubeSat Asteria, and as a lead for Starshade Rendezvous mission, a space-based mission concept under the development for direct imaging and discovery and characterization of Earth analogs. Her lectures consisted of four main questions concerning her vast knowledge of exoplanets. 1. What is an exoplanet? 2. When and how will we find another Earth? 3. Can we go there? 4. If we can't go there, why look? These four questions were answered in her lecture. What is an exoplanet? Seeger claims there are thousands of stars that we know of that are confirmed to have planets around them, which are exoplanets. She shows some posters of exoplanets that were created by NASA and demonstrate the possibilities of exoplanets and how vastly different it would be if we were to live on them. An exoplanet is a planet that orbits a star other than the Sun. On the right are three of those posters shown in the lecture. When and how will we find another Earth? Our Earth is 100 times smaller, 100,000 times less massive, 10 billion times fainter than the Sun. So a method to find an exoplanet will be by transiting planets, where the brightness is measured over time. Dips in the brightness may indicate an exoplanet. Transiting exoplanets have a certain pattern on their graph. On the right is a graph that demonstrates a transiting planet in front of a star. Can we go there? Not for now. Seeger talked about different methods that may be possible in the future that could take us to exoplanets. One idea was a 1-kilometer array of lasers that would push a sail in space up to 20% the speed of light. If we can't go there, then why look? Seeger spoke of methods to find out the composition of exoplanets' atmospheres. Using spectra, we can find planets that are Earth-like. Without using spectra, we wouldn't be able to determine differences between Earth and Venus that may look very similar using transiting methods, but are vastly different. We can use transiting planets to determine the composition of the atmospheres. Planets that are very absorbent atmospheres will appear to have a larger area over the star. One important idea was that each molecule has a unique fingerprint in how it absorbs radiation. So we can clearly determine what molecules are abundant in atmospheres. What interested me about this lecture is the different methods that we have in finding exoplanets, and the methods that we have to determine the molecular composition of a planet's atmosphere, even though it may be light years away. I also found the can we go there portion to be quite interesting, as there may be ways that we can travel long distances within a human lifetime in the future, and as an aerospace engineer, I feel like that would be something that would be relevant to my career. But that's all I have for this presentation, and thank you.